A single mirror can withstand temperatures of up to 1,000 degrees Celsius, while a blast furnace requires temperatures of over 2,000 degrees Celsius to melt steel. The human fascination with mirrors dates back to ancient civilizations, where polished metal surfaces were used for both decorative and functional purposes. In the 16th century, the first glass mirrors were developed in Italy, using a technique known as silvering to create a reflective surface. However, these early mirrors were relatively expensive and fragile, making them inaccessible to the general population. It wasn't until the late 19th century, with the invention of the silvered glass mirror, that mirrors became more affordable and widely available. But how do these seemingly simple objects work their magic, allowing us to see ourselves in a way that's both fascinating and often unsettling? To understand this phenomenon, let's start with the basic components of a mirror: a reflective surface, typically made of glass or metal, and a coating that enhances its reflective properties. The most common type of mirror coating is aluminum, which is applied using a process called sputtering. When light hits the aluminum coating, it bounces back, creating the illusion of a reflected image. But what happens when light hits the glass itself? According to the laws of physics, light always travels at a speed of approximately 299,792 kilometers per second in a vacuum.
However, when light encounters a material like glass, its speed slows down, causing it to bend or refract. This refraction is what allows us to see our images in the mirror, as the light is bent and reflected back to our eyes.
But did you know that some mirrors can even reflect infrared radiation, invisible to the human eye? This is because the aluminum coating is highly reflective across the entire electromagnetic spectrum, including infrared and ultraviolet radiation. In fact, some specialized mirrors are designed to reflect radiation in specific frequency ranges, making them useful for applications like thermal imaging. However, these advanced mirrors require complex coatings and materials, making them much more expensive than traditional mirrors. But what about the science behind mirror images? According to the principle of reflection, the angle of incidence is equal to the angle of reflection. This means that the image we see in the mirror is essentially a virtual representation of the object, rather than an actual physical copy. In other words, the mirror is simply bouncing light back at us, creating the illusion of a reflected image. But what about the curvature of the mirror? A concave mirror, like those used in telescopes, can focus light rays to a single point, creating a magnified image. On the other hand, a convex mirror, like those used in security cameras, can spread out light rays, creating a reduced image. The choice of mirror curvature depends on the specific application, whether it's magnification, reduction, or something in between. But that's not the strangest part. Some mirrors can even be used to manipulate light in ways that defy our everyday understanding of physics. For example, a special type of mirror called a dielectric mirror can reflect light at angles that would be impossible for traditional mirrors. This is because dielectric mirrors use a combination of thin layers of materials with high and low refractive indices to create a highly reflective surface. And then there's the phenomenon of total internal reflection, where light is completely trapped inside the mirror, unable to escape. This occurs when light hits the mirror at a shallow angle, causing it to bounce back and forth within the mirror's surface. But what about the materials used to make mirrors? Traditionally, mirrors were made from glass, but today, many mirrors are made from more exotic materials, like silicon or even crystals. These new materials offer improved durability and resistance to scratches and corrosion.
However, they also require complex manufacturing processes, making them more expensive than traditional glass mirrors.
But what about the impact of mirrors on our daily lives? Mirrors play a crucial role in our self-perception, allowing us to see ourselves from multiple angles and perspectives. They're also essential for applications like astronomy, where mirrors are used to collect and focus light from distant stars and galaxies. In fact, the largest mirrors in the world are used in giant telescopes, capable of resolving images at incredible scales. But that's not all. Mirrors are also used in medical imaging, like MRI machines, where they help to create detailed images of the human body. And then there's the psychological aspect of mirrors, which can influence our self-esteem and confidence. Reflection through the reflected image mirrors offer a unique window into the world of physics. However, excessive mirror use can also lead to negative consequences, like decreased self-esteem and an unhealthy obsession with appearance.
So what can we learn from this seemingly simple object?
Through the reflected image mirrors offer a unique window into the world of physics, demonstrating the power of reflection and refraction. They also serve as a reminder of the importance of self-awareness and self-reflection, encouraging us to examine our own thoughts and emotions. And as we continue to push the boundaries of mirror technology, we may uncover even more surprising secrets and applications. In conclusion, mirrors are more than just a simple reflective surface. They are a complex tool that has captivated human imagination for centuries. So next time you look in the mirror, remember the incredible science and technology that's at work, creating the illusion of a reflected image. If you found this fascinating, subscribe for more incredible stories like this and hit like to support our content.